In this chapter, there are two types of FRQs. The first one is the one that we already studied, which is the one from Basketball, where you state a confidence interval, check the conditions, do the calculations, and make a conclusion. It's called a one sample Z interval for P. So you're given some kind of proportion and you do all of this stuff. There's another kind, which we're learning today, which is very similar. It just has two samples. So your job on the test is to be determining which one of the FRQs is the one sample one and which one is the two sample one. The one with the two samples will have two samples. The one with one sample will have one sample. It won't be hard to tell, I promise. Okay. So state the parameter you want to estimate. In this case, your parameter is going to be P1 minus P2. You're going to have two samples, and you're going to subtract. And the percent confidence. So you have to do two things. You have to say what you're doing and the percent confidence. In the plan, you identify the inference method. In this problem, it would be a two sample Z interval for P1 minus P2. And this is the annoying part. Check conditions for both samples. Okay, now can you pause and get your yellow sheet out, please? Okay, the do step is going to be calculations. What are we doing in this chapter? What's the title of the chapter? Yes, confidence intervals. Okay, so you look at the confidence interval thing right here. This is basically one of the places that your eyes are going to go on the test. You're going to go to this confidence interval thing, and you want to find statistic plus or minus critical value times standard error of statistic. And you're going to use this formula for every confidence interval. It's just that the things change, the stuff that goes inside. Okay, so after you write this down, flip to the back. Find the part of the formulas that has to do with P1 minus P2. How many lines down is the P1 minus P2 section? Where is it in the table? This part, right? You see it? Okay, so your statistic is right here, P hat 1 minus P hat 2. It's the same thing as what you're trying to estimate, it's just your samples. Plus or minus, critical value is still Z star. And the standard error is this big guy over here. I didn't need that many lines. And then your conclude is going to be the sentence for interpreting the confidence interval, not the level, the interval. Okay, so let me go over this again. State. You're going to state what you want to estimate and the percent confidence. Plan. You're going to say what you're going to do and check the conditions. Do. You're going to calculate the confidence interval. Conclude. You're going to write the conclusion sentence for interpreting the confidence interval. Okay. Only way to learn this is to practice it. So we're going to do an example next, but before that, we have this little bit. I left way too much room. Sometimes when you do an experiment, at the end of the experiment, you'll have a starting proportion and an ending proportion, and you'll subtract. And that's where you'll find a lot of the confidence intervals that you'll do in this section. The conditions are a little different when you have an experiment because there's no random sampling. So what you're going to do is look for the words random assignment. Usually you're going to look for the words random assignment. That'll tell you that you're working with an experiment. If you're working with an experiment, you can skip the 10% condition completely. You don't even have to write it. But just because this is notes, we're going to say no random sampling. So 10% condition does not apply. I'm going to write that because it's notes. And I'm probably going to write that in the keys for stuff. If I do the team test key or I do problems, you're probably going to see this. You don't have to write that though. It's just like me explaining. Does that make sense? So if you've got random assignment, you could skip right to large counts. I'm just writing this so you could see what happened. Okay, and then large counts is the same as you would expect. NP is greater than or equal to 10. N times 1 minus P is greater than or equal to 10. But we like it when it's experiments. When you see that random assignment, your brain should go, oh, I don't have to write down as much as I would have before. I can skip the 10% condition and move on, which I like because I'm lazy. Okay, now once you get done with this, the next thing is the arts and crafts. I'm going to start mine on a new page. You do not have to, but I'm starting mine on a new page so it all is on the same page. Also, you all know you don't have this class tomorrow, correct? Okay, while you're doing your arts and crafts, I want you to take a look at the problem and make sure that you see that there's two samples. Can you tell that there's two samples? Okay, so then you know that you're supposed to be looking at this line here on the yellow sheet. And if there was just one sample, you should be looking at this line here on the yellow sheet. So one sample, two sample, one sample, two sample. Okay, and on Wednesday, on the block day, all we're gonna do is 4 FRQs. And we're just going to do, it's just repetition to try to start to memorize. Okay, so there's nothing new. It's just repetition. Okay, state. 95% confidence interval for P1 minus P2. I'm getting that because I could tell that there were two samples. So because there's two samples, I have a P1 minus P2. Okay, now when you do a difference problem, you have to make sure to define who comes first and who comes second in your subtraction. It doesn't actually matter. To be honest with you, I have to have two correct answers on my answer key. But for me, I'm going to do the really, really complicated thing and say the first thing is P1 and the second thing is P2. So in this case, they gave us women. No, they gave us men in the sentence first. It says random samples of working men and women. So I'm going to say men minus women. If you hate that, you could do women minus men, and I would have to have that correct answer on my answer key also. But I'm just going to choose the first one that they say to be 1 and the second one that they say to be 2. Really scientific there. Yeah. Okay, anyway. Men minus women who consider job security important. Okay, 95% confidence interval for P1 minus P2, the true difference in proportions. And then I just sort of started copying off the problem. So true difference in proportions of all working men and women. I just needed to state my subtraction order who consider job security important. Yeah, honey. With the subtraction, yeah, for me, yeah. Most of the time, just because I'm the laziest human being of all time, I will tell you which way I want you to subtract so that we all have the same thing. But again, I usually just pick the first thing to be 1. Okay, anyway, plan. 2 sample Z interval for P1 minus P2. Okay, right now you guys only know 2 different ones. You know a 1 sample Z interval for P, and you know a 2 sample Z interval for P1 minus P2. Those are your only 2 options. Okay, now let's see what you remember. What's the first condition? Random, nice. Okay, so I check back up. Independent random samples. Random samples, check. Make sure that you check both of them. This one's got an S on it, so I'm covered. Nice. 10%. I'm going to do these separately. You need to do them separately. I actually wrote a bunch of notes on your chapter 7 test, of which I need to return to you, that says you need to check if there's two samples, you need to check them separately. Okay, so start with the men because it told us men was P1. So 944 men surveyed. So N equals 944 is less than 10% of all working men. I think that's probably true. N equals 806 less than 10% of all working women. I think that is also true. What's wrong? Jordan? 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 What's wrong? Okay. Okay. Large counts. Okay, I'm going to start with the men. So I have 802 is greater than or equal to 10. What's 944 minus 802? Is it 142? 142 is greater than or equal to 10. 709 greater than or equal to 10. 93? No. 90. 97? 97? Why can't I subtract? It's not a big deal. I don't need to subtract for my job or anything. Okay, let's pause here. You guys have any questions about where any of that stuff came from? This is really chapter 7, so shouldn't be terrible. 12. Any questions at all? Anything? Do you know where these numbers came from? Okay, so this is n times p is greater than or equal to 10. No, it's good. I want you to ask. I bet you there's 10 people in here that don't know. Okay. Does this make sense? The formula n times p is greater than or equal to 10. Okay, so n in this case was 944. Yeah, and then p is 802 over 944, and so the 944s cancel. Exactly. Okay, you. Okay, so we have statistic plus or minus. Oh, yeah, sorry. On the AP exam and my test, you do not need to write this formula out. I'm doing it because I just want it to like, bury itself into your brain so you can't forget it. Okay, in this particular problem, the statistic is p hat 1 minus p hat 2. Over to the side, I'm going to write p hat 1 minus p hat 2 equals. Okay, so scrolling up back to my problem, p hat 1 is 802 over 944. And p hat 2 is 709 out of 806. Don't worry that it's negative. It's not a big deal. Okay. What is the critical value for 95% confidence? 1.96. And if you guys don't have that memorized yet, that's fine. You could do inverse norm to your heart's content. Hopefully your calculators like left the stuff in there for you with the parentheses. You could check it. Okay. Standard error. Okay. 0.85. 1 minus 0.85 over 944 plus 0.88. 1 minus 0.88 over 806. That's all underneath the square root, by the way. You have any questions about my inputs there? So first proportion, 1 minus first proportion over first sample size. Second proportion, 1 minus second proportion over sample size. Okay, now I suggest doing these separately. You don't have to, but I like to. 0.85, 1 minus 0.8.85 divided by 944 plus 0.88, 1 minus 0.88 divided by 806. Point 0.032. You guys have any questions about the calculations, where I got any of that from? All just calculator, really. I think we're good. Okay, last thing for this, and then we have to write something after, but this is the last bit of this problem. We are 95% confident that the interval from negative 0.062 to 0.002 This is the last question here. I guess it wasn't too bad. Mr. Talbot's arts and crafts make things better. Well, a couple of things here. First thing I want to do is console you about the weirdness of the number. Because you just got some answers with some really weird decimals. Okay, so these are percentages. So if you look at this first one, you move the decimal over 2 spots, that's negative 6.2%. That's actually not that small of a number. Think about it, right? 6.2%, negative 6.2%. So this is saying negative 6.2% to positive 0.2%. 0.2% is a really small number, but anyway, it's not as small as it looks because they're percentages. What this means is the majority of my range is negative. Can you guys picture that, like on a number line?
Yeah.
Most of it is negative. Okay, so if you come over to P1 minus P2, that means in general, P2 is a bigger number. Because if you're subtracting and you get a negative, that means the second thing was bigger. So that means in general, because we did men minus women, the women were more concerned about job security than the men were. However, it goes on both sides. Some of the values are negative, some of the values are positive. So can you see that sometimes the women cared more, most of the time, but there's a little bit where the men cared more. Okay, what you do is you say, look for zero. Is zero contained in your interval? Yeah, zero is in there, which means there's a possibility of no difference. Since zero is in the interval, there's the possibility of no difference, so you do not have convincing evidence. Okay, so you're gonna say it like this: since zero is in our interval, there is the possibility of no difference between men and women. We're not going to add that part, but we do not have convincing evidence because zero is a possibility. That's it. We did it. It wasn't too bad, was it? Let me show you my joke though. I really like my joke. And I think that you should use this joke in case any of the Math 3 kids or pre-calc kids are asking you about stats for next year. I think that should be your response to them. Mhm. So if anyone asks you about stats for next year, just make sure they know this first. Mhm. A lot of them are nervous about AP pre-calc, so they're like,
Are they getting